Hi all, hope you're fine. This is Monisha. Today's topic is about Davis-Putnam-Logman-Lowland DPLL algorithm. This DPLL algorithm is a complete backtracking based research algorithm. It can be used for solving the Boolean SAT. SAT means a satisfiability problem. The SAT involves determining if there is an assignment of a truth value with either the value of true or false to a variable in a Boolean formula that can make the entire formula to be true. For example, if you have some Boolean expression, you're supposed to have the entire Boolean expression to be true. If all the expression has been true, it has a satisfiability problem. So it has an assignment of truth values to be true for all the expressions for this DPLL problems. DPLL algorithms. The steps in this DPLL algorithms are unit propagation, pure literal elimination, decision making, backtracking. First discuss about unit propagation. This unit propagation has a class of only one literal. It's a unit class. This one literal can be determined to make a class true. For example, if you have only a class of A, then A must be true. If A is true to a class, it has a satisfiability problem. So the class A is satisfied. The next one is a pure literal elimination. It means literal must appear with only one polarity. Polarity means either it may be have only all positives or only all negatives. If it has only one polarity across all the classes which has been assigned the truth value to make all the classes to containing true. In order to simplify a formula, we are supposed to make one polarity for all the truth values in the classes. For example, if A appears in the positive form in all the classes, never as not A, then A can be said to be true. The next step is decision making. It's also called as splitting. We will apply decision making if neither unit propagation nor pure literal elimination applies. If both not applies, then the algorithm picks a variable, assign the truth value either may be true or false, and recursively check whether this assignment leads to a solution or not. If it leads to a solution, then we can make it as a decision and verify all the truth value as a true class or not. This is a branching step where the algorithm tries out for different possibilities of variable assignments to make the class satisfiable. The next step is a backtracking if the variable assignment leads to conflict. For example, if one or more class become unsatisfiable. When the class become unsatisfiable, if some of the entries are assignment in the truth value has false, then the class became unsatisfiable. If you find some conflict or some classes becomes unsatisfiable, the algorithm can backtrack and flip the variables of truth values and try again. For example, if you find a false in one class, you can backtrack the algorithm and flip the variable truth value as false to true. Once it became true, you can try again. Even if the backtracking fails to find a solution for any assignment, after flipping, we can declare the particular formula is unsatisfiable. It shows you the pseudocode of DPLL algorithm. This DPLL of formula F is supposed to apply unit propagation to simplify the formula, then apply pure literal elimination to simplify the formula. If the formula is satisfied, we can return to we have identified the solution. If this formula contains an empty class that's an unsatisfiable, it it will return false. At that case, you're supposed to choose a variable of x from formula f, and we have to try this DPLL algorithm formula with x is equal to 2. Until you get x is equal to true, you can recursively try again and again to make this class satisfiable. Even though the recursive has been assigned as false, it seems the particular equation has false. It's not satisfiable at all. It has been considered as unsatisfiable algorithm. Consider the formula A are B and not A, are C and not B, are C and not C. We will check whether we have a unit literal or not. We have we have two literals in the first three expressions. In the final expression, we have only one literal. So we'll apply unit propagation on that not C and make C is equal to false. Once C has become false, the value for the false is 0. Where the C has been located has become vanished with the value of 0. So A are B and not A and not B. C in second, third expression has been vanished. Not C expression also has been vanished. The second step, we can apply pure literal elimination. We will check whether we have only one polarity over there. It has both not A and not B. Not A and not B. So we can't apply a pure literal elimination. Next, we will apply unit propagation for both A and B. We will assign A is equal to false. Not of false became true. So not of A became true and not of B became true. Now A are B and A and B, all these formula is satisfied since all the classes are now true. You can practice more examples for this DPLL algorithm. Let us see in the next class. Thank you.